Welcome, everyone. Thank you for joining us on our officially what is our third event. We're really excited. We started with embodied carbon in general, and then we kind of took it the step further to talk about life cycle assessment. And then now we're on to step 3 of what feeds life cycle assessments, of what feeds embodied carbon, and that is environmental product declarations. So thank you all for coming out. And we are still a fledgling organization, so we really appreciate your early support. And of course, again, encourage you to check out clfalberta.com. Lots of good video information. We've had a few of our presentations, or sorry, our previous presentations are up there, but then also some from other regional hubs that have lots of good information surrounding carbon and impacts and cover a variety of topics. You know, blowing agents and mass timber and EC3 tools. So there's quite a few things going on out there. And then also to check out the carbonleadershipforum.org as well. So that's kind of our main other page for sharing information and research. And if you've had a question about carbon, I would say that's a good place to start. And someone might have already asked that question, and there might be a good group discussion or forum on it. So just encouraging you to check out all those resources and get more information about carbon. But we're very happy today to focus on some Alberta carbon. I don't think there's anything else. We'll hop right to it to stay on time. So I'll let Ignacio introduce our speaker today. Thank you, everyone.
Thank you, Kristen. It's an honor for us not only to have Chris here with us today, but a very eloquent day to be doing this, Earth Day. So let me begin by wishing everybody a happy Earth Day. And as I mentioned, it's very interesting to have the ability to deliver this message on Earth Day. But without further ado, I'll introduce Chris. Chris founded Climate Earth. He's the president and chief executive officer of Climate Earth. He founded Climate Earth in 2008 to create innovative and efficient digital solutions to measure and manage environmental impacts. Today, the company is the leading provider of automated EPD systems with over 30,000 ready mix and block EPDs generated. The company works in all areas of concrete, having created the first cement EPD under the new product category rule, as well as the industry's first ever product-specific aggregate and precast EPDs. Prior to Climate Earth, Chris was VP of a Fortune 500 computer company and CEO of 3 Silicon Valley software startups. He holds a bachelor degree in economics and an MBA from the University of California, Haas School of Business. So without further ado, let me introduce and welcome Chris to deliver this incredible fundamentals of EPDs presentation. Chris, all yours.
Okay, thank you. Appreciate the introduction, and it's really delightful to be talking to everybody on Earth Day 51. It's amazing it's been that long since we've been having Earth Days. They seem to be getting a little bit more important in the world. I couldn't help but notice that our country, I'm down in the United States, if you haven't figured that out, announced today that we're going to reduce emissions by 50% by 2030. Pretty ambitious goal. So I'm kind of excited about that. I think it's important environmentally, and I also think it's important economically. So hopefully we can all take advantage of the opportunities that arise from the changes that are happening on the planet and around the world. As Kristen mentioned, we're going to be talking about EPDs. I understand you're all experts now on life cycle assessment, so I won't go into much about that, but it will be occasionally brought up because it's a foundational technology for producing environmental product declarations. Ignacio did a great job of introducing me, but I'll tell you a little bit more about Climate Earth, but first, sort of a roadmap for today. We're going to go into EPD fundamentals, and give you sort of what I call the ABCs of EPDs, and then talk a lot about the business role that EPDs are now taking and how critical we think that is to the future of concrete and construction in general. We'll then talk a little bit about the technology of EPDs and EPD automation, which is, of course, near and dear to my heart. And then we're going to get a little technical. EPDs are strange little documents, and so I'm going to give you a five-step process for how to read one. And then I'm going to close by just on one slide about how we see EPDs evolving even further in the future. So hopefully that's what you signed up for. I also want to say that I'm quite interested in your thoughts and questions as we go along. I've got my chat window opened up down below, and if you'd like to enter something in the chat window and you would like me to pause for a minute and answer it, that would be wonderful. Just put a little star, a little asterisk by your question if you think it might be appropriate. I love that, so I'd prefer they all come dynamically. But also, if you don't put that out, I'll wait till the end and we'll have a regular Q&A session at the end. And my advance is a little, there we go. A little bit more about Climate Earth. As Ignacio mentioned, I came out of Silicon Valley where I had a long career, mostly in software, actually 90% in software. And way back in 2008, saw this thing called life cycle assessment and carbon accounting emerging, and thought it was going to be the accounting system for the sustainable economy. And I think it's turning out to be quite true, but also felt that it was a very manual and labor intensive process and that it needed to be automated. So the first half of our life as a company, and we still do today, we work with Fortune 500 manufacturing companies of all sorts to model and help them report globally on their supply chain impacts. So examples of customers in that arena are General Motors Corporation, which is still one of our largest clients, but way over on the other side, Merck, the big pharma, is also a client of ours. But beginning in 2013, we began to invest in the concrete industry. That's when we introduced and produced the first concrete EPD in the country for Central Concrete. And today, I spend 90% of my time on the concrete industry, and that's our strategic focus. And in particular, focusing on automation of EPDs. Our core product, and I don't mean this to be sort of an advertisement, hopefully it's some background information. I think it's always helpful to know what we do so you can put my comments in context. But we offer a suite of products called the Carbon Clarity Suite. The core of that offering is our EPD generator, which currently automates the production of EPDs, meaning you can, after a 90-day sort of setup period we call, where we do some LCA work with you, after that you can generate an EPD online in a matter of seconds. And we've produced and have up and running generators for ready mix and for block. We also do more traditional EPDs for cement and aggregate. And we're getting some pull to automate those as well. So I think you'll see us by the end of the year with products automation in at least one of those categories, most likely cement. The other thing is that we offer digital marketing tools to help producers market their new expertise. And we do believe that a digital transformation is going on in business. So everything we do is digital, and our EPDs can communicate with lots of other systems, and I'll talk about why we think that's important in the future a little later on. So let's get into the meat of the presentation. An EPD, or Environmental Product Declaration, is essentially a report about a product. But it's a third-party verified report based on international standards, and it's used to provide environmental information about a product. And that product can be anything from potato chips to construction products. Mostly they're done in the business-to-business world. And they've become, I think, the de facto standard for environmental reporting, because they don't make a judgment about your product. They simply give you the facts, and they're very often compared to a nutrition label on food. You know, as I like to say, the sugary cereal doesn't say "don't buy me" for your kids. It just gives you the facts on the side that shows how much sugar is in that cereal. An EPD is very similar to that. They're also comparable by and large. You certainly can't compare a concrete EPD to a steel EPD. And there's lots of progress being made in increasing comparability, because this is what the architectural and engineering and contracting construction community really want. The buyers of products, they want to be able to compare one concrete product to another, or one window to another, like they can compare price. And of course, they're verified, as I mentioned before. So that's the basics of an EPD. What does an EPD measure? So you probably learned in life cycle assessment last month, that life cycle assessment is a discipline that focuses on the environmental impacts of the entire life of a product or a process. So in the case of concrete or cement, that includes raw materials, the material extraction, material processing, the manufacturing of the product, the cement in a cement plant, or the ready mix in a ready mix plant, as we're illustrating here, the transport between each of those, the use of the product once it's installed, and the end of life. So that's a classic life cycle assessment. As you probably well know, EPDs for, by and large, all North American construction materials cover what we call cradle to gate. Technically, that's, we call it raw material extraction, which we call A1. You might have learned this in your LCA. A2, the transport, and A3, the actual manufacturing inside your plant. We don't measure anything that happens after, for example, ready mix or cement leaves the plant. That's an important thing to remember, especially if you're in the architecture engineering community and you're looking at a whole project. The EPDs only don't measure the whole life cycle of your project. So a lot of people say, oh, so that's all upstream. I thought what was really important was operational carbon when we look at a building. And what happened? Why embodied carbon? Is this a fad that's just going away? I mean, who cares about embodied carbon? Well, this chart talks about why we're starting to focus on embodied carbon. So for many years, the architects in particular and engineers focused on building efficiency. And what happened is, with double pane windows and efficient HVAC system and passive systems, the annual operating carbon of a building has come way down. And so all of a sudden people started realizing that internationally, the materials in construction, the carbon footprint of the materials that go into buildings is 11% of global emissions. So it's a big chunk that we've been ignoring. In addition, there's this notion of time value of carbon. You know, a typical building, let's say it takes 2 years to build that building, or 2 years to build a long stretch of new road. What's happened is the embodied carbon, which I've shown here in this chart on the right, over the 20-year life of a building, the embodied carbon occurs now in the first 2 years, and it takes 20 years for the total operational carbon to catch up. So it's a big bubble of carbon that happens now, whereas the operational carbon sort of slips out over time. And so it's both a big number and it's now. So that's the reason that the focus is on embodied carbon. It's not going away. It's highly recognized now as a critical factor in CO2 emissions. Does anybody have any questions so far? I see the chat room is totally empty. But this is a really important concept about how sort of an underlying reason that we're focusing on embodied carbon and EPDs that measure that impact. Okay. So because of the shift, the recognition that embodied carbon is an enormous part of carbon emissions, and that those emissions are occurring now when we're in sort of this critical time around planetary global warming. And because EPDs are this international standard and a non-judgmental, they don't have to give you a green stamp of approval, they're starting to become a new purchase metric. And they came, when they first were introduced into construction, I say before 2018, probably before 2017, they were basically a tax on a green job, right? Okay, you're doing a lead project. The lead project says they need an EPD, you give them an EPD and you get some points, lead points for it. Nobody even looked at the number, which was pretty amazing. But it's now a buying criteria. And this is happening all over North America and Europe, and starting to happen in Asia as well, though they're a little bit further behind. One of the things I look at to measure the long-term usability and likelihood that this is fundamental to business, besides the global trends we talked about a minute ago, that it's 11% of global warming, is I just look at this new tool called EC3, which came out of the Carbon Leadership Forum, sponsored by them and then funded by Skanska and MKA and Webcore Builders and some others. The tool is designed to bring in EPD data and help architects and engineers use that data to make purchase decisions. And what we've seen is in 15 months, they've gone from basically zero when they were launched at Greenbuild 15 months ago to over 10,000 users today. It's just phenomenal growth. And we've also seen the AIA, the American Institute of Architects, last June made a long-term strategic commitment to reducing embodied carbon. We also see this happening in governments, local governments all over North America. So this is a phenomenon that's here to stay. And another way to think about this is it's adding, especially around ready-mix concrete, which is in most cases the final product for that. Where cement goes into ready-mix as a substantial consumer of ready-mix concrete. In this new world, the embodied carbon is becoming a purchase metric, as is demonstrated by EC3. And as I mentioned already, this is being driven by government, by commercial operations, and by major corporations that are doing a lot of build out. Amazon, Microsoft, New York, New Jersey, Port Authority. I know that's down in the US, but $15 billion worth of infrastructure projects already funded. In the last few months, I've talked to Turner Construction and Hines, both large organizations that are looking seriously at their strategy for embodied carbon. Oh, I got a question.
Yay, yeah, I was about to say, we just got a question.
The question is the reason it is becoming a purchase metric is the carbon tax. The simple answer to that is not yet. A carbon tax could drive it even further. Right now, we're basically seeing two things. When Amazon puts up a new distribution center, I'll use them as an example, or Microsoft, or the New York, New Jersey Port Authority, when they put up a new building, and these are big concrete projects. I mean, an Amazon data center is a massive slab pour, 20,000 yards. An Amazon distribution center is typically a 270,000, sorry, I'm going to use square foot measure, building. And they're basically saying, if you want to play on our project, you need to have an EPD, and we're going to use it to help decide which concrete producer we're going to select. So what's happening is and this is more on my next slide, but you have to still meet all the constructability and structural requirements, but now the requirement is at how low a carbon footprint can you also meet those. So it's mostly commercial and a little bit of government. For example, but that's happening here in North America. It's also starting to happen in the provinces in Canada. But California, of course, New York are starting to implement, are right now working on policies where there will be not a tax, but a 2 or 3% credit given to the low carbon provider. And that's a nice incentive to be the low carbon provider. I hope that answer wasn't too long, but basically it's commercial drivers, carbon credits coming on projects coming from governments, and ultimately probably a carbon tax, if it's implemented, would be a driver as well. And I have a lot on this. Here's one more slide on it. I call it the GWP is the new compression tester. And I've already talked a lot about this, but I think another data point about whether this is permanent or not is we're now supporting 300 plants in North America, mostly ready-mix and quite a few with our automated generator. So they've made a business commitment to making EPDs an integral part of their business. And the questions just came up. So more of a corporate responsibility incentive. And yes, for companies like Amazon, and no, and maybe for governments like New York, New Jersey Port Authority, where they're giving a financial incentive, it is still driven, it's in the public interest. So I think you can say it's a corporate responsibility incentive, but it's also a business incentive when your biggest customers are saying they want them. We're seeing a decline in, for example, lead projects and an increase in a request for EPDs. So I hope that answers your questions. You're good at typing, Wes. Maybe you can say yeah or nay or ask another one. I look happy to answer. But anyway, I think the commercial demand from corporations, the public demand from governments, and a lot of producers that are just saying this is happening. We want to get ahead of the curve, and I suspect a tax will likely drive this even harder in the next few years. And I didn't mean to hammer this with too many slides, but I also want to say that this creates an opportunity for ready-mix producers in particular. And the simple reason is so many engineers say, just give me my 20% SCM mix and it'll be fine. I want a 5,000 PSI 20% SCM mix with such and such a slump. Well, if Amazon or Microsoft or the state of California or the Oregon or Vancouver in the future is saying, no, we want that at the lowest possible carbon, suddenly they're going to have to start giving producers performance specifications instead of prescriptive. And that opens up an opportunity for closer collaboration and getting involved in the sales cycle earlier. And I'm seeing that, I'm getting that feedback from some of our larger clients. It's happening. And they're seeing it help them win business that are requiring low carbon. But because these are often large jobs, it's also bringing them closer to some of the big engineering firms in their region. And they're winning, they believe they're winning other deals because of their expertise in low carbon concrete. Cool, I got another question. Are the EPDs generated for your clients resulting in them working to try to lower the embodied carbon in their products? The answer is absolutely. As I like to say, the QC managers of all of our customers just got a more interesting job. They now have a new design metric and a new test metric. We're seeing the tools used in laboratories where the design engineers are taking an existing mix, seeing if they can drive the footprint down, maybe working with their admixture provider to see if they can accelerate set time, but maintain the strength and workability of the mix, but redesign it at a lower carbon footprint and then sell that as their low carbon design. So yes, absolutely. Most of our customers start out with 30 or 40 EPDs per plant. And as you can see, we have, as of this morning, we have 31,614 EPDs. So an average of 100 per plant around the country and around North America and Canada. And most of those new EPDs are focused on improving the mix design with respect to carbon reduction. Okay, so that's all I really have to say about sort of this notion, are EPDs just going to go away? Is it in my business interest to ignore them? Is it a kind of a fad thing, or should we be paying attention? Um, and hopefully you can see that there are some long-term effects, long-term trends in place. And one I didn't mention is that most of the major cement producers have already committed to be carbon zero by 2050. So the cement plants are working on technologies and processes for reducing energy in the kiln, and maybe even whole new types of cement to replace Portland cement. And I'll get to pricing in a little bit, but I wanted to go now to a sort of quasi-technical and talk about the process for creating an EPD, and then we'll go into pricing. And but the traditional EPD, not automated, such as what we did here for Lehigh Cement in Canada. This is and I'm using these as guideline budgets. This has nothing necessarily to do with Lehigh. I think they're actually quite a bit faster, thanks to Ignacio. But what we say is there's essentially 4 steps to producing an EPD. A basic paper-based PDF EPD. And as I've mentioned, it's driven by these international standards. The core EPD standard is ISO 14025, which was published in 2006. So it's sort of relatively new. The first stage is data collection, and we always budget 60 days with the client, and I think this is pretty common to collect the data. We have automated forms now for ready mix. We're getting there for cement and other materials, not just spreadsheets. But usually we're working with a QC manager and or a technical services manager, and they're really busy. So we have to collect, and the data we collect is who are your suppliers? How do the materials get to your plants? How far is that distance, which we calculate obviously with Google. And then what's the annual energy use of your manufacturing facility, of each of your plants? And so we budget 60 days for that. And that's where you're doing most of the work. We meet with you every week in a Zoom call like this to coach you through the process and help you find shortcuts and solve problems and that sort of thing. But the bulk of the work is actually yours. After that, it's up to us. We have to write a full life cycle assessment report, which talks about these technical terms like the goal and scope, the inventory, the life cycle data quality, inventory analysis, and calculates the impact assessments. We also work with you to create the design of your EPD during that process. And that usually takes about 30 days. And then we have to push the report and the EPDs to a verifier. In North America for concrete or other construction products, it's usually ASTM, NRMCA, or UL Environment are the 3 major ones. But this is the work that happens to produce a static report for a number of products. In cement, as in our example here, it was 5 cement products. And generally with cement, having a standard EPD that's fairly static was a great solution because it's good for 5 years and there's not a lot of change in cement products. Well, change is changing. Change is coming in cement. We're seeing a lot more iterations in design of cement products with more blended cement. Also, a lot of work on reducing the energy in the kiln and the fuel types, and even carbon capture and sequestration at the flue. lots of talk about getting cement down dramatically. If we look at the EPD automation process, the customer still has to go through this one-time, we call it system setup. Same thing. For ready-mix concrete, we generally then produce 30 initial EPDs for you for each plant. But once that's done, you have a system to generate EPDs and it becomes part of your business. The pain is over. You can now generate for an annual subscription unlimited EPDs, all you can eat. And in addition, we'll come in once a year. If you have new suppliers, new processes, water washout facilities, carbon cure, changes in your plant operations, we'll incorporate that data into your new EPDs and you're refreshed. And that process is usually very fast and efficient, a couple of weeks at the most of part-time on your behalf. Okay, so here we go. How much do these darn things cost? And I decided to be real transparent. First of all, I have to say our pricing is still, we're not big enough to deal with currency exchange and stuff. So we bill in US dollars, but these are Canadian dollars. I thought it would be useful to see it in Canadian dollars. But for example, if you have a 6-plant operation, sort of a smaller urban operation, it's going to cost you $3,646 per plant to go through that setup process that I described earlier, that 90 to 120 day process. And after that, you're going to pay us $1,000 a year for each plant. And for $1,000, you get 100 EPDs, 500 EPDs, as many as you can or want to create. You know, a typical plant is probably going to do about 60 or 70 to 100 a year. You know, at 100 a year, it's $10 a piece. And you get your annual data refresh. So as I said, for that $1,000 per plant per year, we come in and we also refresh your data. So every year, your data and your EPDs are fresh and current. And I played around with some different project sizes, but I'll let you do that kind of comparison. And as you can see, as you drive down, as we work on larger projects, because the setup time, the setup cost for us is writing that LCA report and the incremental cost for doing an additional new plant, the report and your work with you gets a little more complex, but the cost per plant goes down pretty dramatically as we get to more and more plants, as does the annual subscription per plant. So this is not, you know, it's not cheap to pay $21,000 for a 6-plant operation up front, or $1,000 a month, but it's compared to the scope of an operation that does 1 million yards a year, 1 million meters a year. It's very, very small.
There's just a question, Chris, from Anna. If during the year you change suppliers or get new suppliers, will there be an extra cost?
No.
Great. I have one quick one actually to also add. Do you know if this is a similar cost to getting an EPD for another product, or is this cost very much only just for, you know, concrete?
So these are most EPDs for different products are still done in the old-fashioned way, where they get a static booklet, and that's for good reasons in most cases, that they don't change their product very much. We think there's going to be an increasing need for for automation because we're going to see a lot more push for innovation like we're already seeing in ready mix. So a one-time EPD, like for a cement plant or something like that, is going to be, and that EPD lasts for 5 years, it's going to be in the range of $20,000 Canadian plus or minus, depending on the scope and size of the operation. So if you amortize that over 5 years, it's $4,000 a year, something like that's ballpark. We're very careful when we bid aggregate facilities because, you know, we've done aggregate operations with literally hundreds of conveyor belts and massive acres of processing, and then sometimes we've done much smaller ones. So the scale for aggregate, for example, can go up and down. It's fairly constant for cement, you know, around 20K.
Thank you.
But yeah, to be clear, the annual subscription, I mean, we have no limits on the number of suppliers you can change. You could change all of them. If that started to happen, we'd probably raise our prices, but you can change all the suppliers you want. You can add new facilities, like we see companies adding recycling of concrete. All of that, we just bundle, all that updates go into your new EPDs. Am I scrolling on the chat? I'm just checking the chat. Oh, I'm getting more questions. I'm not scrolling down.
It's okay. I think we asked the latest one, and then I think there was an
Okay.
auto-generated verification question. If there was a, for auto-generated EPDs that you develop, is there an expedited process for verification?
So the EPDs that we generate, for that first, let me go back a little bit. Oops, I'm going back in the chat. We don't want to do that. I want to go back in the. So this first verification that we do after the setup is manual. After that, when you enter data for a new mix design, which the milliseconds, it's online and your verification is on demand. It's instant. It's done with software algorithms. About 1/4% of the time, we have what we call an outlier that is quarantined. And then that has to go through a manual review, and that usually takes a day or two. And usually we had a customer that had a couple of those weird mixes, and it cost them $250 to get them verified. So it wasn't break the bank kind of stuff. And then we worked with the client to make sure they don't have other outliers. So I hope that answered the question. The verification process, you enter an EPD, you enter a mix design in a browser, you get your EPD instantly and it's fully verified, stamped, ready to go. We also integrate in concrete with the major quality control systems. I don't see everybody's profile, but if you're in the ready mix business, there's systems like Command QC or Quadrell or Stonemont, and these are the systems for managing your set of concrete mixes. We're connected directly into those, so to generate an EPD with those, you just select the mix on their console, push a button that says Get EPD, and they send us the data, and we send you back an EPD within a couple of seconds. So depending on the sort of the maturity and the audience, the architects and engineers are really interested in particular on this comparability question. And the answer is, are EPDs comparable? It depends. For ready-mix, the answer is yes. They're highly comparable as long as you're comparing mixes that are performing the same function. But if you put out a bid and you've got a bid for a 10,000 PSI column, all the bids you get for that 10,000 PSI column are comparable, and the EPDs you get, even if they don't come from us, are comparable. We've done an analysis that's going to be published at NRMCA's site in the next week or so. We worked with NRMCA and Athena, the Canadian company, nonprofit company that does mostly manual EPDs. And we are within 0.8% difference, and most of the time we're exactly right on. So ready-mix EPDs are comparable, and the reason is that we've standardized, one new message, we've standardized, the PCR committee standardized on the underlying data that we use. Cement is, I say largely yes, but I have a business head on this. The product specific are rapidly emerging, and so much of the emissions is in the kiln, basically the creation of the clinker, the cooking. In most places, the CO2 emerging from the kiln and the energy is monitored very, very closely with very sophisticated methods. And so that big number is highly reliable. And most of the other numbers are very, very close. So I like to say largely, yes, I think you can be very comfortable comparing one cement EPD to another. And that's an opinion that I have based somewhat on my experience as a business person that used to making decisions where I'm not quite concerned about the exact within 1% or 2% or, is fine. Some more deeply LCA professionals might tell you, no, they're not comparable because there's noise in the data, a little bit of noise in the data. Wood and steel, the other core products, both of these don't have product-specific EPDs. So if you're doing a whole building analysis and you're an architect, you can throw in a wood EPD that's an average, and you can get sort of a general idea of how that wood's going to impact the whole structure. But every laminated beam supplier in North America so far is going to provide you with the same EPD. It's an average, and you can't get, they're both going to have the same number. So they're not comparable because there's nothing to compare. And then the other thing about wood, I'm in many cases a big fan of wood. I like to say I love my wood mantle and my furniture. But there's lots and lots of complex questions around the sustainable harvesting of wood. To me, the biggest one is it's really hard to know if you're doing sustainable harvesting and the tractors or stuff are going through the forest every year and cutting out 5% of the trees, you're churning up a lot of CO2 in the ground. That's really hard to measure. And the other question for me is a question of scalability. If we say every new building up to 10 stories was built with a wood frame, we'd have a real problem. We would have a wood shortage, I'm sure. But that's a bigger question. And then steel also lacks product specific and has industry average. You can get EPDs on tubular steel, on I-beams and such, but it's average. And they've never included fabrication, which is the final step in fabrication for most projects. It's smaller than in the steel mill impacts. but it's meaningful, and we don't include those in for complex jobs with a lot of bending and welding and fixing the. It's a pretty important carbon element that's not accounted for. I hope that wasn't too long. Let's see, did I get one more here? Oh, thank you, Kristen. National Ready Mix Concrete Association. Yeah, that's a North America, national, US national.
Yeah, I was just making sure there's lots of acronyms all the time.
Yeah, I'm sorry.
Not at all.
Just a little bit of a look at a cement EPD, and we're running out. I think we're getting close to time, so I should speed it up a little bit, right?
Yes, please. Thank you.
Do you have a time bell on me? You want me to stop in like 3 minutes?
Yeah, I wasn't sure how much you had left, but it would be great if there could be still about 5 minutes for questions.
So cement APDs, we've already talked about them. We're seeing a lot of investment in blending technology, a lot of new fuel options, and a lot of innovation in cement. The current industry average EPD for concrete or for cement is 1,042 kilograms. It's going to come down to 920 with a new, I think that was just released. But you can see Lehigh has a new blended cement that's 632 kilograms, so it's a significant reduction. And I'll give you the fast how to read an EPD. Make sure you're looking at apples to apples, that you're comparing an EPD that's being proposed for exactly the same job. Look at the global warming potential. In ready mix, older EPDs than February 2019 are not comparable, so you need to look at the date. That's true of all EPDs. Make sure they're on the same product category rule. Second, look for uncertainty. That's required to be published. In this case, this is an EPD that used a cement EPD, so there's no variability. But if there is, it's in the concrete EPD. And also, if you're really a stickler and want to make sure you're doing apples to apples, look at the primary sources of data. And in ready mix, we're all required to use exactly the same data, but if it's not published, it's not in the EPD, it's a problem. So make sure that you double check that if you're doing this comparison manually. And so 2 more slides. EPDs are now, they're like a compression monitor. It's the fact that they're sort of a government-y standard report is less important that they give you a number. And also the digital EPDs, the instant EPDs are driving innovation and becoming more of a strategic choice. We're seeing other companies beginning to try and move more towards automation with spreadsheet-based solutions. Whole building LCA is lagging. This is a real problem for architects in particular, and want to look at the whole building before they solidify a design. But once you've chosen your core, like it's going to be a concrete core, then EPDs can be used effectively. And last of all, we see, talking to customers, 3 new things. One we've talked about a lot, but I'm hearing customers now saying they're going to have an EPD for every single mix they design, because that it's part of the mix. It's like, what's the compressive strength? And it's essentially free to have one for every mix. We're seeing it, I've talked about this, but more and more used for strategic comparison and digital analysis. And we're also, we're going to be integrating, we're already integrating with other construction systems, such as building information modeling systems, whole building LCA, and purchase analytic tools. The EPD is the building block for all of those tools. And all of those BIM systems aren't going away, and they're going to want to incorporate environmental data. Autodesk already does to some degree, and we know that's going to increase. So I don't have anything else. That's my last slide, and I took a little longer than I thought. And I see a hand being raised.
Yeah, that's okay, Anthony. It looks like Anthony has a question. Anthony, go ahead.
Hi, thanks. Yeah, thanks for the presentation, Chris. I was wondering, relating to the Climate Earth EPDs, at least in the Canadian context, I know oftentimes a lot of the ready mix suppliers, they don't want to share like the details of their concrete mix design, like the SEM content or whatnot. And you know, I've taken a look at some of these generated EPDs, and all you see is kind of like a mix number, and it's kind of hard to discern what's in there aside from, you know, the strength, and you know, maybe it's 56 days or 28 days to cure. But I'm just trying to think about how do we actually integrate this information into our LCA studies, because it's kind of hard to discern what these mixes are. We just have kind of a code. So what would you say on that front? So
you're exactly right. Everybody who's buying concrete wants to know the mix designs. And
which they seem to share in the States, but not in Canada for some reason.
No, they don't share them in the States either.
No? I thought they were.
No, they do not. EC3 is trying to get ready mix producers to release that data. The only way to get that data is to tell your ready mix supplier you've got a big job and you're really interested in the specific mix design, and they will share it with you. And I know Arup down here does that a lot, and they ask their engineers to collect all the mix designs for every project they do, and they put them all into a big spreadsheet database. So they're starting to learn about mix design. But the ready mix producers consider that to be proprietary information. And we offer a tool that's we call it the Concrete Designer, that does produce a report that shows the summary of the EPD, the mix design, and how it compares to the average. But that's a product we sell to the concrete producers, and they choose to share or not share those reports with you. They use it both for designing new mixes and innovation when they don't want to have an EPD out there for some weird mix. And they also use it for engaging more closely and collaborating with their engineering or contracting partners to decide on what's the right mix design for the application. EC3 is trying to start a program to have a value add EPD where the ready mix producer agrees to send certain parts of their mix design, like the cement content, to them, so they have that. But yeah, it's a big issue for buyers of concrete. I don't know how to help you about that. I have all the data. But I'd be out of business if I gave you any of it.
I understand. Great, thanks.
It looks like we have a great question from Klaus. What is the purpose of measuring EPDs for ready mix when it can't be compared apples to apples with wood, steel, or other products, so you can get a complete building number?
So that's a great question. Basically, the EPD can feed a whole building LCA. So it's possible the more accurate and emerging whole building LCA tools will use EPD data. And though the wood people have to come up with product-specific EPDs, when we have that, then the architecture engineer can design a building and compare the total footprint of a wood core design versus a concrete design. Right now, once the building design has been decided, then you're going to be purchasing concrete for the concrete applications. And at that point, those EPDs are highly comparable. So the answer is sort of yes and no. But there's a strong interest in, and I think it's ultimately going to be a competitive advantage that concrete is highly flexible. It's the only one of those raw materials of the core ones that right now has the ability with current technology to reduce the carbon footprint substantially. And that's a different perspective than, you know, the cement industry getting whacked for being a high carbon material. That's changing. And concrete is ubiquitous. You know, the planet's made out of gravel and sand. And limestone is ubiquitous. And so I think concrete has the strongest long-term potential. I don't know, steel is steel. I mean, you can only recycle so many cars. And you still have to remelt them, and it's a high carbon intensive process. And I think, and there's a lot of questions with wood, and until those are answered, I don't think we have an answer for wood. Except it's probably a good solution for at smaller scale. I'm really concerned that you couldn't. What is Architecture 2030 says, in the world we're building one New York City every 33 days. Mm-hmm. You know, if we had to build one New York City out of the current stock of wood in North America, we'd probably be in big trouble with, you know, we wouldn't be able to do it.
Right. So what I understand is it's more for when you've already decided to go concrete. Now you can compare. Yeah. Comparing that to a wood building is a different thing, and of course you would have to get a different carbon numbers, and it's a different decision.
And that's a big hole in the whole process, is that architects need better tools for that upfront decision.
Agreed. That's one of the purposes of Carbon Leadership Forum, I would say. Yeah. So we can. It is. So thank you guys for being part of learning that today. I did just learn today, I think Lafarge Canada became one of the first Canadian concrete producers to provide mix-specific EPDs. Is that right? I think. Anyways, just something we can all maybe go check out LinkedIn or the presses for that information in Canada. But
yeah, Lehigh, Vancouver was, I think, first.
Good to know. Thank you. Sorry, Ignacio.
And the little guy Butler is also providing mix specific in Vancouver. And you'll probably see EPDs coming out from Lafarge as well in Canada.
Oh, perfect. Sounds like the trend is happening. If you guys are okay to stick with us, there's one more question, if we're okay to have a few more. Oh, it looks like there's lots of mix specific information. So sorry, my sources are maybe need to be checked, but that's the link there that we were pulling from. But Chris, there's another quick question. How do you address potential changes made to the initial mix design during weather, aggregate, saturation, admixture addition?
Another great question.
Mm-hmm.
To some degree, we rely on the relationship that the concrete designer has, or concrete provider has, but some of those changes happen, you know, day to day based on weather, and we really don't deal with that today. You know, if one day it's sunny and nice, and all of a sudden the next day the temperature plummets on the East Coast, you're going to have a slightly different mix design. You might modify it slightly with different admixtures and such. And the system doesn't account for that very well. I have had a request for as-built analyses, which would be quite easy to do. So, put in all the mixes that were actually delivered and the number of yards after the fact. But frankly, day to day, when you're in the middle of a construction product, you've got to keep pouring, and you're going to pour that concrete, whether it's good, bad, or indifferent, because you're not going to slow down the project. But you could do an after the fact analysis to see how close you got, and it would be generally pretty close.
Looks like there was kind of a follow-up if there's a tolerance range for the system.
I'm not so there's Oliver is asking that. Does he mean tolerance plus or minus for the EPD results, or tolerance for what passes through the system to be verified for modification? You mean to the mix design? Okay. So the question is there tolerance range for the modification to mix designs? And we're finding mix designs are modified for the same function fairly often. And some producers want to keep the same mix ID, and so the system supports a versioning capability. If a customer enters the same mix ID and enters new design constituent components, the system says, is this a version 2 or is this a mistake? And you say, no, it's a version 2, and we produce a new EPD. The old EPD, the rules of EPDs require that they live for 5 years, so the old EPD still lives. But the version 2 is what the customer is now selling, and it's pretty easy to distinguish that. They show up in the drop-down menus at the program operator sites and such, that you want to look at the version 2.
Looks like another question from Anthony. Have you seen any concrete producers generate EPDs that have higher GWP than the industry average? Oh, great question. The industry average. I'm assuming that's the industry average EPD. Will there be an issue with concrete producers only publishing their lowest carbon mixes but not publishing their higher carbon mixes?
So yes, we see plenty of EPDs for higher than the industry average. And this is because of structural requirements. I mean, there is a need. Constructability and structural requirements still come first over environmental requirements. So you'll see, you might see a really high 8,000 PSI, MPA, not 8,000. I think I'm North America. I have to put my Canadian hat on. A high MPA mixed design that has for some reason has a high set time or fast set time requirement. It'll be loaded with Portland cement, and that'll be way above the average. And we see things like that all the time. The second question, lowest carbon mixes, but not publishing their higher carbon mixes. I think there's probably a little bit of that customers are not always publishing their high carbon mixes, especially if they think it's a low volume sales mix. But we're also, because of the tools we have for demonstrating, we have a whole building tool. Once a concrete building is decided, we have a tool that a software application we provide to our customers where their local architects and engineers can go and enter all the mixed designs, or all the, not mixed designs, the compressive strengths in the application and the total yards, and get a high, medium, and low carbon footprint looking at for the whole project by mix type. And that gives you a framework for how low can you go and which mixes to focus on. And for that reason, we've seen some customers suddenly that are using that tool want their high to be really high so they can really take credit for the low, you know, so they'll do EPDs that are higher.
Interesting. They're playing the game.
Yeah, of course, everybody does that. I mean,
easy to reduce if you're
the game they're not playing is they're playing less and less of the overspec game. So, you know, the engineer overspecs a little and then the producer overspecs a little over that. We're starting to see conversations that are saying, oh, we're not going to, cutting out the Portland cement is going to be a big help. So maybe let's see if we can get closer to the real engineering specs and not over design the mixes.
That's great. Well, I think we are over time. Thank you for the people sticking with us, and thank you for staying to answer questions, Chris. Yeah, there'll be a recording of this coming up. So if you guys want to share that with people that couldn't make it today, more than welcome to do that. Everyone that attends will get the copy, and
great talking to you.
Will also be posted to our website. Thank you, Chris.
Take care.
Thank you, everybody. See you at the next. Oh, sorry, our next event. I don't know when it is yet or what it is. We're looking at the EC3 tool, but we'll keep you posted about that too. So keep an eye on us on LinkedIn and social media, and we'll be sure to see you guys in a couple months. Thank you.
Bye-bye.
Thank you very much.